We are presenting on our project Rapid EndoGraft Fenestration, developed under the guidance of Alan Dawson. When patients with complex aortic aneurysms aren't fit for open surgery, surgeons use a Physician Modified EndoGraft, or PMEG. To make these work, the surgeon must manually create fenestrations or holes in the graft to maintain blood flow to critical branching arteries. Currently, these holes are reinforced with PTFE grommets and wire, which are hand sutured to the graft. This allows the surgeon to see what's happening under X-ray and helps guide the implantation. However, hand suturing is incredibly tedious and time-consuming, and our goal is to design a tool that makes this reinforcement rapid and reliable, significantly reducing the time spent in the operating room. Why does speed matter? The OR is expensive, including the surgeons, the OR itself, and the support staff. Our stakeholders need a robust, cost-effective device that offers consistent reinforcement while getting rid of preparation time and material costs. Ultimately, we would like to create a prototype that can be marketed to surgeons and the funding organizations to move toward regulatory approval. To tackle this, we developed two distinct prototypes. The first one is a bioglue dispenser and the second one is a stapler design. The bioglue dispenser allows for a radio-opaque marker to be chemically secured directly onto the graft. The mechanical solution uses a radio-opaque staples to reinforce the fenestrations. Both designs aim to replace the slow needle and thread method with a point-and-click efficiency. Our most significant challenge was our customer liked both designs. This forced our MSD group to pivot. Instead of choosing one, we split our focus into two. While every team member contributed to both designs, we divided our primary concentration to ensure that both the mechanical stapler and the bioglue designs reached their expected results. This cross-sectional view shows the level of precision we are aiming for with the titanium wire and the fenestration alignment. We would like to thank Dr. Doran Mix for letting us observe his work in the OR and providing materials, and a special thanks to Alan Dawson in the MSD office and the 3 DDD students for their incredible animations of our devices. Thank you so much for your time.